Hello everyone, welcome back to our channel that is the Chemical Engineering. Myself Dr. Kirti Zare. Today I am going to introduce to you about the Runge-Kutta Fourth Order method, which is the same as like the Runge-Kutta Second Order method. In the earlier video I had uploaded the Runge-Kutta Second Order method, and in today's we can discuss about the what is exactly Runge-Kutta Fourth Order method, which is similarly to solve the differential form of the equations. Generally, this method is utilized into the Navier-Stokes equations in the heat exchanger. It can be also used into the draw the complex profile with respect to the heat exchanger, heat transfer, again different equipment of the heat exchanger, which is including the evaporator, condenser and the reboiler and the so on. It is also useful into the PBR or the continuous stirrer tank reactor, where you can see the what is the exactly relation of the PXY or the TXY curve. So there are the different advantages of this particular type of the Runge-Kutta method. Again, this is the same like approximate method. Let's start for the numerical statement, that is dy by dx minus y is equal to the 0, in which given data is y is equal to the 2, x0 is equal to the 0, h is equal to the 0.1, find y at x is equal to the 0.2. So let us start for this. Now here the fourth order method means you are supposed to consider the four coordinate, four slope of the Runge-Kutta method. So let us K1, which is calculated as h, which is the function of the x0 to the y0. K2, that become the h, which is the function of the x0 plus h by 2 y0 plus k1 by the 2. K3, that is equal to h, which is the function of the x0 plus h by 2. Again it is the y0 plus k2 by the 2. K4, that become the h, which is the function of the x0 plus h y0 plus the k3 is equal to the 1 by 6 k1 plus 2k2 plus 2k3 plus k4, right? And yj, which is calculated as y0 plus the k. So this is the simplified form of the equation through the Runge-Kutta fourth order method, right? So let us start for this particularly form of the numerical, right? So for the firstly for the h, this is called as the step function or the size function. So h is equal to the xn minus x0 by the n, right? So h they are already mentioned, that is the nothing but the 0.1, that is the xn. So it is given again 0.0, 0.2 and x0 become the 0 and you are supposed to calculate the n. You are getting the value of n is equal to the 2. Hence it is the approximate type of the method. So accordingly this numerical statement you have to perform the 2 iteration for going the approximate form, right? So let us start for the iteration number 1. So K1, that become the h. So h value become the 0.1, which is the function of x0 y0, right? But if we are going to see our function, so they are given dy by dx minus y is equal to the 0. So they are not given the any form of the x over here. So you are supposed to consider the, this is the minus y is equal to the 0. So they are giving the function in the form of a y only. So you are supposed to consider only y here. So that become the y0. So y0 value become the 0.2. Right. Now let us calculate for the K2. So that become the 0.1 into bracket x0 plus h by 2, but hence they are not giving the any form of the x here, so you are supposed to consider this only. So y0 value become the 2 plus k1 is 0.2 by the 2. If you are going to simple solve this, so you are getting the value become the 0.21. That become the K2. Now next value become the K3, that is again 0.1 into bracket y0 value become the 2 plus K2 value become the 0.21 by the 2 become 0.2105. So let us calculate for the K4. So that become the H. So 0.1 into bracket y0 plus the K3. So y0 value is the 2 plus K3 value become the 0.2105. Right? So if you are going to calculate, you are getting the K4 value become the 0.22105. Right? Now let's calculate for the overall K, that become the 1 by 6. That is the K1 0.2 plus 2 multiply by 0.21 plus 2 multiply by 0.2105 plus 0.22105. Right? Through the getting the K value become the 0.12034. Yj, that is nothing but the y0 means 2 plus 0.21034. So yj value become the 2.21034. Right? So just calculate for the iteration number the 2. Right? So it become that again you have to calculate the K1, that is nothing but the again h, which is the 0.1, which is a function of the y0, because they are not going to mention the x form over here. Right? So now you have to consider the y, you have to consider the yj become the y1. So it multiply by the 2.21034. Right? So now our new 0.221034. Right? Let us calculate for the again the K2. So H means that is 0 point into bracket the Y0, that become the Yj or Y1. So it become the 2.21034 plus K1 means this value, that is 0.221034, that divided by the 2. Right? Will become the 0.23208. Calculate for the K3, that is equal to the 0.1. Again y0, so y0 value become the 2.21034 plus K2 become the 0.23208 divided by the 2. Now through the simple calculation become the 0.2326. Right? Now let us calculate for the K4. So it become the 0.1 into bracket the y0 value become the 2.21034 plus the K3. So K3 become the 0.2326. Right? So we are getting the K4 value become the 0.2449. Right? Now let us do the calculation for the K. So K, that is become the 1 by 6. Right? 1 by 6 into bracket K1, it become the 0.22103 plus 2 into multiply by the 2.23208 plus 2 multiply by the K3 value, that become the 0.2326, right? Plus K4 value, that become the 0.2449, right? So you have 0.23244, right? Now just calculate for the next yj, that become the y0 plus the k. So y0, now mu means this value become the 2.21034 plus k value become the 0.23244, right? So if you are going to calculate the simply, so yj value become 2.44803, right? So this is the yj value, right? With respect to the Runge-Kutta fourth order method, because here you are supposed to calculate only n is equal to the